Let's look again at how to solve equations. We look at the equation 2x plus 3 equals 10x minus 5 again. Now, the traditional way of solving an equation is not really by doing these logical calculations, but with derivations. And the argument then goes something like this. First, we start with the equation itself, like this, and then we say that we subtract 3 from both sides. And this gives us 2x plus 3 minus 3 equals 10x minus 5 minus 3. And then we simplify the expression. So left hand side gives 2x and the right hand side is 10x minus 8. Then we subtract 10x from both sides and we get 2x minus 10x equals 10x minus 8 minus 10x. We simplify again and we get minus 8x equals to minus 8. Then divide both sides with minus 8. We get minus 8x divided by minus 8 equals minus 8 divided by minus 8. And finally simplifying, we get x equals 1, like this. So we have shown that the solution is x. Now this may look like a calculation, but it actually is not. We are just adding new conclusion steps to previous steps. So when we start from assuming that 2x plus 3 equals 10x minus 5, by sequence of these conclusion steps, we arrive at the conclusion that x equals 1. In practice, this means that we have proved that if the equation holds, then x equals 1. We have proved an implication. Because we only have proved an equation, and because we only have proved an implication, we also need to show that x really does satisfy the equation, that we don't have a false root here. We check the solution usually by looking at both left-hand side and right-hand side of the equation. So if x equals 1, then we see that 2 times x plus 3, substituting x equals 1 gives us 2 times 1 plus 3, that's 5 on the left hand side, and on the right hand side we get 10x minus 5, x equals 1, we get 10 minus 5, which is 5. So both left and right hand side have the same value, so x equals 1 does satisfy the equation.